Okay, here we have problem 33, and it says consult Appendix E, and this is our appendix. And assume circular orbits. What is the magnitude of the orbital velocity in meters per second of the Earth around the Sun? What is the radial acceleration in meters per second of the Earth toward the Sun? Repeat parts A and B for the motion of the planet Mercury. So we know each planet moves in a circular orbit and therefore has an acceleration of A rad equals V squared over R. So the radius of the Earth's orbit is R equals 1.50 times 10 to the 11th power meters, and its orbital period is 365 days, which equals 3.16 times 10 to the 7th seconds. Okay, so that is for A and B for the Earth. Now for Mercury, we're going to do orange. Mercury. There's another page actually. Okay. The radius is 5.79 times 10 to the 10th power meters, and the time is 88.0 days, which equals 7.60 times 10 to the 6th power seconds. Okay. So for part A, B, for Earth, the answer is V equals 2 times pi times R over T equals 2 times 3.14 times 1.5 times, I'm going to continue down here, 10 to the 11th power over 3.16 times 10 to the 7th power, which equals 2.98 times 10 to the 4th power meters per second. So that's for what is the magnitude of the orbital velocity in meters per second. Now we're going to do what is the radial acceleration of meters per second of the Earth toward the Sun. And that is A equals V squared R, which equals 2.98 times 10 to the 4th power, in parentheses, to the 2nd power, over 1.5 times 10 to the 11th power, and that gives us 5.92 times 10 to the 3rd power, negative 3rd power, meters per second squared. So that was for what is the magnitude of the Earth and what is the radial acceleration, the Earth toward the Sun. Now we're going to do that for Mercury. So part A for Mercury would be V equals 2 times 3.14 times 5.79 times 10 to the 10th power over 7.6 times 10 to the 6th power, which equals 4.78 times 10 to the 4th power meters per second. So that was for A for Mercury. And then B for Mercury, which is towards the sun, is A equals 4.78 times 10 to the 4th power squared over 5.79 times 10 to the 10th power, and that equals 3.96 times 10 to the negative second meters per second squared.